going to have a look at in the case where you have different class sizes. So, and I'll explain that in just a few minutes, what I mean by a different class sizes using a pure past question. If you don't know what a histogram is, this is just a pictorial representations of information being given to you. So let's have a look at the question and then dive into the solution to that, and I'll explain that step by step. So make sure that you watch the video to the end. From the question, we are giving informations on a patient at a clinic, right? Just assume that you are a nurse or a doctor at a hospital. You have to keep a record of whatever you are doing. So the idea of a histogram is that you can see the picture clear just as compared to this written aspect, right? So some people are not okay with the mathematics terms, so let's use a visualization, right? Something that you can see better. So that is why we have one tool called a histogram. So let's see exactly how a histogram looks like and how we can use that to answer the information being given to us. So from the question, we are having the ages of the patients, right? So the patient from 11 years to 20 years, how many are they? So they are 8. So this is what we call frequency, right? So how many are they? They are 8, right? So that's the frequency. And then people from 21 to 25, they are what? 16. Right, and the 26 to 30, they are 20, 22, and so on and so forth. So this is what we call frequency, right? So how many people are available in particular class? So this class here, we are having 8 people there, and so on and so forth. Okay, now the first question that is to use the information you have to draw a histogram, right? So how can you draw the histogram? So with this type of histogram, we need 2 things. We call something class boundaries, right? And I'll explain that in just a few minutes. So for you to draw the histogram, you need 2 tools. The tools here are the class boundary and frequency density, right? Most of the times you need the class boundary and the frequencies, but the frequency density is when you have a different class sizes, and I'll explain that in just a few minutes, right? So we are going to use the class boundary and the class sizes which are different, right, to draw a histogram. So this is how the histogram will look like. So something like this. I will do that. I will demonstrate that in just a few minutes. So here you have your class boundaries here, right? Class boundary here. And the frequency density, right? Why density? Because we have a different class sizes. And how do you find, or how do you know that the class sizes are different? Okay, now the first thing first. So we need the class boundary to draw the histogram. Right, so how do you find the class boundary here? You can see that here we are having for you to find the class boundary for a particular age of people, right? Let's say from 11 to 20 years, we want to find the class boundary for that. So what do you do here? How do you find the class boundary? You just pick this guy here, right? You pick this guy and then that guy. Is that okay? So the last person in this this age group here, and then the first person in the next age group. So here we are having 20 and then 21. Is that okay? So look at what I'm doing, 20 and the 21. So what is the difference between the two? The difference is 1. That is 20 minus 1. So 20 minus Oh, sorry, let's say 21 minus 20, right? So 21 minus 20. Is that okay? So 21 minus 20, that's equal to 1. Right? If it is equal to 1, then you take half of that. Any answer that will be 0.5, right? 0.5. So this is how you find the class boundary. Is that okay? So you just pick the last person and then the first person here, subtract it and then divide by 2, whatever the value may be, right? So what do you do with the 0.5? So you take a 0.5 from this guy and add that 0.5 to the upper. So 0.5 from the 11 and then 0.5 to the upper, which is 20. That's how you got the class boundary, right? So 10.5, and then you add the 0.5 to the upper one, which is 20.5. So we are taking the 0.5 from the first person, from the first guy here, and then we add that to the last person, right? So that is how you find the class boundary. So when you do that, you can see that from here we are having 21 to 25, and then when you take a 0.5 from 21, you are going to get 20.5, and then you add that 0.5 to the 25 here. That will give you 25.5. Is that okay? So this is how you find a class boundary, right? This is how you find a class boundary for all. So when you check the last age here, you can see that from 41 to 50, and then we are having what, 40.5, and then 50.5. You can see the difference between these two guys and that guy is what 1, right? From here to here, you can see that is just 1, and then you divide it 1 by 2 will give you what, 0.5. Then the answer that you get, you subtract that 0.5 from this guy, the smallest guy, and then give it to what, the elderly person, right? So 0.5 from this guy, that will be 40.5, and then you add that 0.5 to what, the elderly person, which is 50, so 50.5. So this is how you find what, all the class boundary. Okay, now that we got one, we know that we need 2 different tools to draw what, our histogram, right? So now the next one is what, either the frequency or what, the frequency or density. So when do you use the two different tools? So maybe in the case of what, a frequency, that is when you have an equal class size, and I'll explain that in just a few minutes. What I mean by the equal class size, let's say we are arranging the people from 11 to 20 years. So what is the difference? What's the difference between the two? So from 20 to that, you can see that is what, 10, right? The class size, that one will give him 10. So how do you get a class size here? How do you get a class size? So look at this. You get a class size by subtracting the class boundaries, right? Subtract that from that, and which will give you what? Let's say 20 what? 20.5 minus what? 10.5. So that will be what? 20.5 minus what? 10.5. That will be 0, 0, and then 1, right? Can you see? So the difference between the class boundary is what? 10, right? That is how I got a 10 here. It's okay. This is how we find the class boundary. We are doing this thing to check whether we've grouped everybody into equal class of sizes, right? So when I subtract that from that, it will give me 10. What about this? 25.5 to 20.5, right? So 25.5 more is what, 20.5. That will give me what, 5. Have you seen that there's a difference? You have a difference between the two, whereby here you are having 10 here, and the next one you're having what, 5. Obviously that there's a difference. So if this thing happens, then you need the frequency density to draw what, your graph, right? So we need two things. That is what, the class boundary and the frequency density. It's okay. We use the frequency density when the class classes are not what, equal. Okay, now if you subtract everything, you can see that here will give me 10, and then here will be 5, 5, 5, and then the last one will also be 10. So in this case, we are having 10, 5, 5, 5, 5, and then 10. You can see that the class classes, maybe let's say the room that we are going to put them in, they are not equal. If they are equal, then we can just use the frequency. And we have a video on that, you may consider watching that. But in this case, their sizes, the class classes are not equal. Once they are not equal, you have to look for what, frequency density to draw your histogram. Okay, now how do you get the frequency density? There's a way of doing. There's a tool. You have to use this tool to get the frequency density, and the tool here is what, F divided by C. So we just need to know who is F and then who is C. Then we are free to go. Now who is F and then who is C? F is the frequency, right? F here is the frequencies. These are the frequency, right? How many people are in what? The group of 11 to 20 years, they are 8, and then 21 to 25 years, they are what, 16. So these are the frequencies, right? So F here is what stand for the frequencies. What about the C? C is what, the class sizes. Is that okay? So these are the class sizes that we are having, right? So 10, 5, 5, 5, 5 out, and then 10. Is that okay? So these are what, the classes. Now how do you get the frequency? That is the tool that you have to use, what, F divided by C, to get what, the frequency density. Okay, now F divided by C meaning that line by line. So on line by line, so here you are having a frequency. For the first one, you're having a frequency to be what, to be 8, right? To be 8. So the first part will be what, 8 over 8 divided by what, the class size. The class size here is what, 10, right? The class size on the line by line, that is 10. So that will give me what, 0.8. Is that okay? So 0.8. That is how I got the first line to be what, 0.8 here. Okay, so the same way you have to what, tackle everybody line by line. So the next line you consider the frequency is 16, and then the class at its corresponding class as is 5. So 16 over 5, that will give 3.2, right? 3.2. Okay, you need to calculate all the frequency density for what each class or class sizes or whatever the age range. So here I'm having 0.8, 3.2, 4.4, 3.8, and then 5 as well as 1. Is that okay? So now that we got the frequency density and what the class boundary, now we can draw our what histogram. So that is the two things that you need to have at your disposal before you can draw the histogram for a different class sizes, right? Different class sizes. So if the class sizes are not equal, then you need the frequency density and what the class boundaries to do that. If you are enjoying the video, don't forget to subscribe to our YouTube channel. Just share the link so that we can help you wherever you are. Okay, now let's see how to draw the histogram using the information that we are having. This is a very nice graph that I'm having. Maybe yours might be a little bit different from mine. Maybe the graph that we are using is a little bit different from mine. That doesn't necessarily matter here. The most important thing is you to get an understanding first. Okay, now I said earlier on that we need two tools to draw a histogram where the class sizes are not equal. Those are the class boundaries, right? So the ages and what the frequency density. So the class boundaries will be on this as is here, right? The down, they will be on the down here, and the frequency densities will be on this line, right? To be on this line. So you can see this is what my frequency density on this line. Okay, now how do you number? You consider the number here will depend on you. So what I mean by it will depend on you. You just have to look at the smallest numbers in the frequency density and the highest numbers among them. So when you look at the frequency density carefully, you can see that the smallest one is 0.8, right? 0.8 here, and then the largest among the frequency density is 5. Okay, now in number you have to make sure that all these numbers appear, and actually you have to be sure that your graph doesn't squeeze. What I mean by squeeze, that you should cover at least half of your, or more than half of what your entire graph sheet. Okay, now how do you number? So I decided to start from here. So that will be 1 here, 1, and then 2, 3, 4, 5. Have you see? So I'm having all the numbers from 0.8 to 5 available, right? And in fact it has already covered more than half of the entire graph sheet. Is that okay? Okay, now the class boundary, the name of the class boundary start from what? You see that from 0 to what? This guy 10.5. We don't have anybody, right? We don't have anybody, so we are starting the class boundary from what? 10.5 to what? 20.5. So this is the class boundary. Look at the class boundary. So the class boundary start from what? The first one start from what? 10.5 to what? 20.5, right? And the size is what? Is 10. That the 10 is bigger than 5, so this guy has to be automatically bigger than what? These people. This room has to be bigger than this room, right? Okay, so from 10.5 to 20.5. So we are starting at what? 10.5, right? And then we are going to end at what? 20.5. So 10.5 is here. This is our 10.5, the starting point, right? And then we are going to end at what? 20.5. Remember I said that this guy has to be bigger than the next one. The reason being is that the size of this room here is 10, and then the size of the one that follows is what? 5, right? So from here to that is 10.5. I supposed to be at what? 15.5, so that the class size will be equal. But you can see from the question that we are ending at what? 20.5. So that's why I decided to jump from this line and then end somewhere here. So you may decide to shade this portion for what? A clear understanding. So the examiner or whoever is marking your paper can see clearly. Okay, so from here to here, from 10.5 to 20.5. I didn't end here. The reason being that this is what the size of this class is 10. Okay, so from 20.5 to 25.5 is what? The class size is 10. So here, okay, let's see something. Here we have to end on what? The frequency density is what? 0.8, right? It's not up to 1, right? It's not up to 1. So this is what? 0.8. Is that okay? It's not up to 1. So this guy end on what? 0.8 here. Alright. So the next one is what? From 20.5 to what? 25.5. And then they are ending on what? 3.2. Right? They are ending on what? 3.2. So 3 is here. 3 is on this line. And then 3.2 will be what? Here. If you don't know how to count these small bars, you just have to find the difference between what? The biggest interval. So the intervals are 1. So how many subdivisions are within? That is what? When you count 1 by 1, so you get 20, right? So 1 divided by what? 20 will give you what? The size of what? 1 bus, right? 1 subdivision, 1 small subdivision here. Okay, so that is how you just count. If you have any question, just comment down below. Is that okay? Okay, so here we are going to end on what? 3.2, right? So 3.2. So the same thing, you have to shade that portion. So this is how you have to fill in all the spaces one by one to arrive at what? Your final answer. So let's shade the portion there and then come back and check exactly what I've done. So if you've done everything correctly, you should have something similar to this type of a very beautiful graph over here, right? So you consider the last one from the range of what? 40.5 to what? 50.5. This class boundary, the size is 10, right? Obviously that this is a little bit bigger than what the rest of the what the spaces that you are having. So of course the last one, what the first one have the same class size. So the class size of the first one is 10, then that one is so that's the reason why I didn't end here, right? I didn't end here. So suppose I ended at this portion, that would be what? 45.5, and then 45.5, and then 50.5, right? So I need to jump this guy here. So this is what the room for people between the ages of what? 41 to what? 50 years, right? Okay, so this is how you have to tackle this type of a histogram. So one trick here is that you have to pay attention to what? The class sizes, right? Pay attention to the classes. If the class sizes what? Are equal. If once they are not equal, you have to look for what? A frequency density. So the frequency density is what? F over C, right? F divided by C, whereby the F is the frequency and what? The C is what? The class size. Okay. Now the next question says that you should find the mean. So how do you calculate the mean? So the mean for what? The distribution. So you need to know the mean. What exactly is the mean before you can what? You can solve that problem. So what is the mean? So what's the mean? And then which type of the mean that's what we are talking about here. So this is a mean from what? A group data, right? So what I mean by the group data is that the numbers are being arranged, right? They arrange the number from what? 11 to 20, 21 to 20, meaning that we are grouping them. So okay, we are grouping them to avoid what? Multiple works. Okay, now so that's the definitions of what? The mean from what? A group data. So this is what? The sigma fs divided by our sigma f. So the meaning of the sigma fs is what? The summation, right? So summing fx, and then we are going to divide everything by what? The summation of what? F. So this f is the frequency. So this is frequency multiplied by x. Now we know the frequency. We know this frequency, so we know that this means we should add, right? We should add everything together. Then, but we don't know this x. Is that okay? We don't know the x here. So where exactly can we get the x? So it's our duty to go and look for this x before we can find what? The mean age here to correct up to decimal place. That's what the question says. Okay, so how do you get the x here? So from the information being given, for you to find the x stands for what? The midpoint, right? So you can see from my table here I have x. So this x is what? Stand for what? Midpoint of what? Right? Midpoint, right? So midpoint of what? Midpoint of what? The arrangement. Is that okay? So midpoint of these two guys. So from 11 to 20, what is their midpoint? So how do you get that? You just add the 2 and then you divide by what? The 2, right? You add 11 plus what? 20 and then you divide that by 2. That's how you are finding what? The midpoint of the two guys. So 11 plus what? 20 will give me 31. So 31 divided by 2. 31 divided by 2. That should be what? 15.5, right? So 11 plus what? 20. That should be what? 31, right? So we are talking about the midpoint. So 31 over 2. That would be what? 15.5. So the x is the midpoint of what? The ages, right? The arrangements of what? The ages. Is that okay? So this is how you have to find for what? Each what? Category. So here you can see that this line I have 15.5. The next one will give me 23, and then 28, 33, 38, and then 45.5, right? So that is for the x. S is just what? The midpoint, right? Mid values of the two. Okay, now look at what the definitions of the mean is saying. They say summation of what? Fx. So meaning that we should sum fs. F multiplied by s. Now we know f, we know x. So this guy is going to multiply the x, right? So the frequency must what? Multiply the x here. So these are the frequencies. Now that we know the frequencies, right? We know the frequency and we know the x, then we are free to go. Is that okay? What are they saying? They say we should multiply that by what? X. So that will be what? 8 here, right? Multiply by what? 15.5, right? So that should give him what? 124. Is that okay? So you can see this column here, I'm having what? Fx. So this is what? 124, right? So 124. So the same thing applies to the rest of the, then you are multiplying the frequency by the x. So frequency here, that's what? 16 multiplied by what? 23. That will be what? 368, and so on and so forth. So when you are done, they say you should sum. So you have to add everything here. That will be what? 3140, right? So this is the summation of what? Fs. So this is 3140, and then down here says that summation of what? F. You should add all what? The frequencies. So these are the frequencies. We are adding all these values, right? We are adding all this. So 8 plus 16 plus 22 and so on and so forth. When you sum everything together, you can get 100, right? So 100 there. So meaning 3140 divided by 100. That should be what? 31.40. Is that okay? It's set to 2 decimal place, so that will be what? 31.40. Okay, the next one says that I should find the probability that at most 25 years, right? So that's the last question there. They say at most 25 years. What's the meaning of at most? So you need to understand this word first. Okay, you need to understand this. The meaning of at most. At most 25 means that from 25 or downwards, right? 25 down. Is that okay? From 25 years or down, right? So let's go and look for the 25 years down. So which people are below the 25? So that will be 24, 24, 23, and so on and so forth, right? Okay, so go to your table and go and locate the 25 years. I'm not saying the frequency, we say 25 years. So these are the ages, right? These are the ages. So obviously this is the category of what? 25 years. So 25 and below, right? So when, if you don't know, you go here, it means that we are going up. So 25, 26, and 30. We don't do that. It's at most. So that is what? From 25 or down, below 25 years. So these people are what? Below 25 years. So the category is what? 21 to 25 and 11 to 20. These people are what? Below 25 years. So how many are they? They are 16 and 1. 8, right? Those who are between the 21 to 25 are 16, and then those who are between 11 or 20 are 8. So below 25 years is what? 16 plus 8, right? 16 plus 8 will be 24. But remember, they say probability. So the chance that these people will be what? Part of the competition is what? 25 over 100, which is the total. How many are there? How many patients are we admitting at the hospital? They are all in 100. So 24 divided by 100. So when you divide this thing nicely, you can get to 0.24. Okay, so this is how simple you solve this type of a histogram question. If you have any question, just comment down below, right? And if you enjoyed the video too, don't forget to subscribe to our YouTube channel. So thank you for watching.